Today we're going to look at section 5.3, which is called Trigonometric Functions of Any Angle. So our objectives today, we're going to use definitions of trig functions of any angle. We can use the signs of the trig functions and we can find reference angles. All right, so trig functions of any angle. It says the point P, which equals the ordered pair xy, is a point r units from the origin on the terminal side of theta. A right triangle is formed by drawing a line segment from point P perpendicular to the x-axis. Okay, so this is going to be crucial. We are going to be sketching a lot of pictures. And so once again, we're thinking about an angle in general. It has its initial side, which is always on the positive x-axis. And then the terminal side is that ray that just keeps moving around and around and around our coordinate system. Okay, so we're talking about the terminal side that helps form the angle, and we're always drawing a line perpendicular from that terminal side to the x-axis, which would then form a right triangle. So here I just demonstrated within each quadrant what that right triangle would look like. All right, definitions of trigonometric functions of any angle. So remember, when we're thinking about right triangles, we're thinking about, Pythagorean theorem. And when we're talking specifically about a coordinate system with points, we're thinking about connecting the Pythagorean theorem to the distance formula. So it says, let theta be any angle in standard position and let the point P, which is the ordered pair xy, be a point on the terminal side of theta. So just like I showed you in the last slide. So now it's saying if r equals the square root of x squared plus y squared, if that's the distance from the origin 0, 0 to the point xy, as shown in that last slide that I just had all those pictures for, then we could specifically define the ratios. So the sine of theta would be y over r. So once again, think about it. When you're talking about sine of a right triangle, you're thinking about opposite over hypotenuse. So r in this case is always the hypotenuse. Okay, when it's talking about y, well, think about it. The angle is always going to be formed by the terminal side, but the terminal side is connected to where the origin is located, because that's what the angle is in standard position. So if you're thinking about opposite the angle, well, that's going to have to be the vertical side of the triangle. And the vertical side is always when you're moving up and down. So that's the y-axis. So that's why it's y over r. So then when we're thinking about cosine, which is adjacent over hypotenuse, once again, the hypotenuse will always be r. But when we're talking about adjacent, well, that means that it's the side that's right next to the angle. And so what's right next to the angle? Well, the x-axis, so moving left and right. So that's why x is dealing with then the adjacent. Okay, so then tangent is opposite over adjacent, so y over x. And then remember, we can just flip those around to get then the cosecant, the secant, and the cotangent. But remember, we never want our denominator to ever be 0. And the radius will never be 0, so that's why I didn't have to put r doesn't equal 0 for the first two ratios of sine and cosine. All right, so honestly, you don't really have to memorize those definitions here as long as you know how to sketch a picture. So let's take a look at this example. It says, let P be the point 1, -3, and that point, remember, is on the terminal side of theta. So we're going to find each of the 6 trig functions of theta. Once again, we just need to be able to sketch a picture, and then those definitions that I just showed you aren't really going to be necessary to remember. Okay, so if I'm thinking about my x and y axis, we have to think about where is the point 1, -3 going to be located? Well, 1 is x, so that's going to be going to the right. -3 means that's y, that's going down. So that means that we are in the 4th quadrant. Okay, so I know that my terminal side then is in the 4th quadrant where, like, this is my point, 1, -3. Okay, so if that's the point P, I know that I always want to draw from that point P a perpendicular segment to the x-axis. Okay, so there is my right triangle. And I know that I'm going to be dealing with theta then inside the triangle by the origin. Okay, so there's my picture. And once again, if I know that the point is at 1, -3, essentially it's giving me the legs. I know 1 is x, that's the horizontal line, and then -3 is my side that is the vertical. Okay, so then as long as I know two sides of a right triangle, I can always find the hypotenuse by doing either, by doing Pythagorean theorem, essentially. Okay, so remember they called that definition, this is R, so I'm going to use that. So we're going to have 1 squared plus -3 quantity squared to equal R squared. Because remember, they said in the definition that R was the same thing as taking the square root of x squared plus y squared. So that's where they're coming up with that definition. It's really just the Pythagorean theorem. Okay, so 1 squared is 1, -3 squared is 9. So essentially, R is the square root of 10. Okay, remember your hypotenuse will always be a positive value, regardless if your legs are positive or negative. Okay, so now that I have all three sides of my triangle, now I can do the trig ratios. I can do sine of theta, I can do cosine of theta, I can do tangent of theta, and then I can do all the reciprocals. I can do cosecant, secant, and cotangent. So once again, by having this picture sketch, you don't have to memorize, okay, what's x, what's y, what's r. You can now just look at your picture and you can do opposite over hypotenuse, adjacent over hypotenuse, and so on and so forth. So since sine of theta is opposite over hypotenuse, that would be -3 over the square root of 10. But I do want to rationalize this. So remember, that means multiply the top and the bottom by the square root of 10. So I can get rid of that radical in the denominator. So essentially then, -3 root 10 over 10 is going to be sine. Cosine is adjacent over hypotenuse. So adjacent is 1, hypotenuse is the square root of 10. Once again, let's rationalize. So the square root of 10 over 10 is cosine of theta. Tangent is opposite over adjacent. Opposite is -3. Adjacent is 1, so essentially just -3. And then remember, we can flip those ratios around and we can get then our three remaining ones. So remember, I would not go back to this rational thing here. I would go back to what my original ratio was to then flip it around, because otherwise, if you use my new -3 root 10 over 10, you're going to have to do rationalizing again. So same thing here. I would take this ratio for cosine before I rationalized it and flip it around for the reciprocal. So that means that cosecant is going to be the square root of 10 over -3. Cosine, so then secant is going to be the square root of 10 over 1, which you could then just call the square root of 10 if you want. And then -3 over 1, I would flip that around, and that becomes 1 over -3. So there are all 6 of my trig functions. All right, trig functions of quadrantal angles. So remember, quadrantal angles are angles that lie on the axes. So how do we find values of these trig functions for a quadrantal angle? Well, we'll draw the angle in standard position. We'll choose a point P on the angle's terminal side. So once again, it's going to be on one of the axes, but we're going to think about it in terms of having a unit of 1 from the origin. So I'll explain more about that in a second, but we'll always think about a unit of 1. And then we'll apply the definitions of the appropriate trig functions. All right, so evaluate, if possible, the cosine and the cosecant of these 4 quadrantal angles. So when I'm talking about the 1 unit apart, I'm talking about, okay, here's my x and y axis. So here is a point that is on the x-axis that is a quadrantal angle. So 1 unit away would make it at the ordered pair 1, 0. Okay, then up here would be another point for a quadrantal angle. 1 unit away would be 0, 1. Then over here, this is a quadrantal angle at -1, 0. And then down here, it would be at 0, -1. So that's what I want to be thinking about when I'm talking about a unit distance apart. And I know that it said to use like those definitions, those 6 definitions that we talked about a couple of slides ago. Honestly, though, I'm going to give you another hint, and it's going to help us out when we do something called a unit circle. When we're talking about these ordered pairs, we always want to think about cosine being the first number in those ordered pairs and sine being the second number. Okay, so any number that's first is representing cosine, any number that's second is representing sine, and then obviously we can then do the reciprocal of those numbers to get then the secant and the cosecant. And then remember, tangent is the same thing as sine divided by cosine. It's one of those properties that we talked about when we filled out our flip chart. And so we can use that information to get tangent and then flip it around, and then you have cotangent. So this is what I really think that we should focus on when we are doing these quadrantal angles. Okay, so talking cosine. So cosine of theta, once again, if it's 0 degrees or 0 radians, 0 degrees / 0 radians is right here. That's at the ordered pair 1, 0. And like I said, cosine is always the first number in the ordered pair. So cosine of theta equals 1 is my answer. If I'm talking about cosecant of theta, well, remember, cosecant deals with sine. It's the reciprocal. Sine is the second number in the ordered pair, and it's 0. So think about flipping it around. Technically, that's 0 over 1, which means that cosecant would become 1 over 0. But hopefully you noticed I can't divide by 0. So actually there, we would have our cosecant undefined. And those are my 2 answers. If I look at the next one, if I look at 90 degrees, well, remember, 90 degrees is up here. That's where the pi over 2 radians is. Okay, so if I'm looking at trying to figure out cosine, once again, cosine is the first number in the ordered pair. Well, in that ordered pair, it would be 0. So the cosine of theta is 0. If I wanted to then do the cosecant, once again, it's the reciprocal of sine. Sine is 1. So technically 1 over 1, if I was to flip it around, I would still get 1 over 1 or 1. So that's my cosecant. If I want 180 degrees, remember that's over here, which is where the pi radians is. So we're looking at the ordered pair -1, 0. So if I want the cosine of theta, I'm thinking the first number in my ordered pair, so -1. If I want my cosecant of theta, we're doing the reciprocal of that second number in the ordered pair. So 0 is the second number. Once again, that's like 0 over 1. If I flipped it around previously, just like at 0 degrees or 0 radians, I get then an undefined answer there. And then finally, down here would be the 270 degrees or the 3 pi over 2 radians. And so that's the ordered pair 0, -1. So if I'm talking about the cosine of theta, I want the first number in the ordered pair, so it would be 0. And then if I want the cosecant of theta, we are looking at the sine, so the second number, and I want to flip it around. So -1 over 1, if I flip it around, would be 1 over -1. So essentially still -1. Okay, so that's what we want to be thinking about when we're talking about quadrantal angles. All right, so now the signs of trig functions. When theta lies in a quadrant, x and y can be both positive and negative. To help you remember which trig functions are going to be positive versus which ones are going to be negative, we can think about the phrase, all students take calculus. So what does that mean? Okay, well, the A is for like the first quadrant. The S is for the second quadrant. The T is for the third quadrant. And the C is for the fourth. Okay, I'm just thinking 1, 2, 3, 4. Well, the first quadrant, A stands for all, and that's because all the functions are positive. So all 6 of them you won't have a single negative sign, which makes sense because the first quadrant, you're moving to the right, which is positive, and you're moving up, which is positive. All the sides of my triangle will be positive. When I think about then the second quadrant, when I see S for students, well, that means that sign, which starts with an S, is going to be positive. And what is the reciprocal of sign? Well, cosecant. So both of those are going to be the only trig functions that are positive. So this phrase is talking about when we are dealing with positive ratios. So sine and cosecant are the only positive ratios in the second quadrant. In the third quadrant, notice how take is that third word. T stands for tangent. So tangent and its reciprocal cotangent, those are the only ratios that are positive in the third quadrant. And then C for calculus, well, C is the same thing with cosine. And so in the fourth quadrant, cosine and its reciprocal secant are the only ratios that are positive. So hopefully that phrase can kind of help you. But once again, sketching a picture is always going to be the most beneficial thing for us. All right. But if we want to practice using that all students take calculus phrase, let's look at this. It says if sine of theta is less than 0 and cosine of theta is less than 0, name the quadrant in which angle theta, or the quadrant in which the angle theta lies. So once again, if I'm thinking about all students take calculus, if we think about it like this, I'm looking at less than 0, meaning that this ratio is a negative ratio. Cosine of theta is less than 0. That is a negative ratio. So we can eliminate things right away. The first quadrant is where everything is positive. Well, that means that if sine and cosine are negative, it can't be in the first quadrant. If I look at the second quadrant where the S is, that's where sine is positive. Well, that means it can't be in the second quadrant because I was telling you that sine of theta is negative. If I then look at the fourth quadrant where it says C, that's where cosine is positive. But I'm telling you cosine of theta is less than 0, so it can't be there. So the only possible place for these two stipulations to make the angle lie would be then in quadrant 3. All right, so evaluating trig functions. Let's look at the steps. We want to draw a picture based on the given information. I just can't stress it enough. Drawing pictures is going to be the most beneficial thing for you. So sketch them. We are then going to find the missing side of the right triangle. We will find the remaining trig functions. And that was it. Okay, so sketch a picture, find the missing side of the right triangle, and then whatever ratios that they're asking for, we can go ahead and we can do that. Okay, so here we go. It says we are given that the tangent of theta equals -1/3 and cosine of theta is less than 0. If that's the case, we want to find sine of theta and secant of theta. Okay, so once again, if we're thinking about the phrase that all students take calculus, remember that's where things are positive. So right off the bat, because tangent of theta, they're giving us a negative ratio, it can't fall in the first quadrant and it can't fall in the third because that's where everything's positive in the first and tangent is positive in the third. The other information they gave us is that cosine of theta is less than 0, so that means that the cosine also has to be negative. Well, in the fourth quadrant, that's where it's positive. So it looks like it's narrowed it down. The picture that we need to draw lies in the second quadrant. Okay, so if I know that I need to sketch a right triangle in the second quadrant, remember, here's my terminal side. I draw from that point down perpendicular to the x-axis. So here's my theta. So now that I know that theta is there, tangent is opposite over opposite over adjacent. So the side opposite is going to be 1, and the side that's adjacent is going to be 3. Now notice that I need to figure out where this negative sign goes. Does it go with the 1 or does it go with the 3? Well, look at the movement. Think about how do you move to get to the second quadrant? Well, you move to the left. Moving to the left is negative. Moving up is positive. So that's why the 3 is what has to be negative and not the 1. Okay, so now I'm almost done. I now need to find my hypotenuse. So I'm going to do Pythagorean theorem. I'm going to have 1 squared plus negative 3 quantity squared to equal my unknown. I'm just going to call it x squared. So 1 squared is 1, negative 3 squared is 9. So add that up, we get 10, and take the square root. So square root of 10. Once again, your hypotenuse should always be positive. And so now that I have my picture with all 3 sides, I can definitely find the ratios for the 2 trig functions it's asking for. So it's asking for sine of theta, and it's also asking for the secant of theta. So sine of theta, remember, is opposite over hypotenuse. So opposite of theta is 1. The hypotenuse is the square root of 10. Once again, I want to rationalize, so I'll multiply both the top and the bottom by the square root of 10. So the square root of 10 over 10 is going to be my answer for the sine of theta. And it makes sense. It has to be positive because in the second quadrant, sine is positive. So now I want secant. Remember, secant is the reciprocal of cosine. So that means if cosine is adjacent over hypotenuse, I want hypotenuse over adjacent. So the hypotenuse is the square root of 10, and the side adjacent would be negative 3. So square root of 10 over negative 3 is my answer. All right, last concept here, reference angles. So it says, let theta be a non-acute angle in standard position that lies in a quadrant. Its reference angle is the positive acute angle, which we call theta prime. That's what that little tick mark means, is prime. And it's formed by the terminal side of theta and the x-axis. Okay, so you're starting with an angle that is bigger than 90 because it's non-acute. And we will turn it into a positive acute angle formed by the terminal side and the x-axis. So the key here is understanding that we are only dealing with the x-axis when we're talking about reference angles. Now notice that in this picture, I don't have anything dealing with the first quadrant, and that's because all of my angles are positive in the first quadrant because it's going to be between 0 and 90 degrees. So it's only the second, the third, and the fourth quadrant that we really need to work on. Okay, so if I know that it needs to deal with the x-axis, well, notice that my x-axis is always going to be then, obviously, this line right here. And so if I'm looking at the picture here on the far left, my terminal side is in the second quadrant, meaning that it's between 90 and 180 degrees. So how do I make that angle that's between 90 and 180 to be a positive acute angle? Well, I'm going to subtract it then from 180. Okay, so hopefully that makes sense because along the x-axis, that's where 180 degrees is. So if I need something that's positive, obviously theta is something that is smaller than 180. So to keep it positive, it's 180 minus that angle. Okay, here then, if my angle's in the third quadrant, I still need to understand that I'm focusing on the x-axis, okay? And what is closest to that angle in the third quadrant on the x-axis over here at the 180? 180 degrees is going to be a lot closer than over here, which is really 360. So that's why I want to focus on the 180 measure, but this time the angle is in the third quadrant, which makes it bigger than 180. So that's why I have to then take my angle and subtract 180 from it. So that's the difference between the second and the third quadrant. Which angle is, dealing with 180? Is it bigger or is it smaller? And that's how I know how I'm going to have to subtract to get a positive acute angle. And then when we're talking about then an angle in the fourth quadrant, well, fourth quadrant is going to be then where it's closest to 360 degrees because it's almost one full rotation. But because it's not quite that full rotation, it's less than 360 degrees. So then that's why we have to take 360 and subtract our angle from it. Okay, let's do some practice problems here. So it says find the reference angle, which is theta prime, for each of the following angles. So if we're talking about a 210-degree angle, let's think about this. Okay, I'm going to sketch a picture to help us out. Okay, I need to know where 210 lies. So once again, I'm thinking it starts at 0, up here is 90 degrees, 180, 270, and it rounds it out to be 360. Okay, so where's 210? Well, it's going to fall here. It's in the third quadrant. This is where 210 degrees is. So once again, my reference, so that's theta. My reference angle, let me change colors here. My reference angle is going to be this little tiny acute angle. This is what I need to find. So if I'm trying to figure out how do I get that reference angle, which is a positive acute angle, well, when I'm in the third quadrant, that number of 210 is a little bit bigger than 180 on the x-axis. Remember, it's closer to 180 than it is to 360. So I need to take those two numbers and I need to do something with them to get my reference angle. Well, what I'm going to do is I'm going to take the bigger angle, which is 210, and I'm going to subtract 180 from it. Okay, 210 minus 180 is going to give us a 30-degree angle. And so notice that that is a positive acute angle. That's my reference angle. And that's my answer. Okay, so now let's talk about if I'm dealing with it in radians, because it's the same idea. So let's sketch a picture, figure out where 7 pi over 4 is going to be. Now remember, we're thinking 0 starts us here, but then it's going to end at 2 pi. So let's turn it into a denominator of 4, because that's my denominator in my radian, which meant I had to multiply not only the bottom, but the top by 4 as well. So we've got 8 pi over 4 is 1 full rotation for radians. Okay, so if I'm thinking about how is it going to be labeled throughout, okay, once again, it's a positive angle, so I know I'm going to be moving in a counterclockwise position. I forgot to mention that in the first one, but hopefully we're familiar with drawing angles by now. Okay, so I know I want to go in a counterclockwise position. Well, I want to stop halfway over here, so that would be 4 pi over 4. Okay, that's halfway to get me to 8. So now if I want to go up to the top, well, what's halfway between 0 and 4? That would be 2 pi over 4. So notice that means that each quadrant that I stop at, I'm adding 2 pi to the numerator each time. Because 0 plus 2 pi gets me 2 pi on the top. Add 2 pi gets me 4 pi. Add 2 pi means that down here, we're at 6 pi over 4. And add 2 more, now I'm at my 8. So because I'm talking 7 pi over 4, well, 7 is going to be in between 6 and 8. So that means that my terminal side is going to fall here on the fourth quadrant. So that means that this picture, that's my theta, that's my 7 pi over 4. But remember, I want a reference angle. Your reference angle is always going to be a positive acute angle that's always formed with the x-axis. So that's going to be this angle right here. This is my reference angle that I'm trying to find. So notice that my reference angle, I need to use, so once again, this is the 7 pi over 4. I need to use that angle that they gave us, and I need to understand that that is closest to 8 pi over 4. So those two numbers are what I have to use in order to find the reference angle. Since 7 pi over 4 is smaller and I want a positive answer, I need to take the bigger number, subtract the smaller number. And so hopefully we notice then, same denominator, I keep the denominator, I'm just subtracting the numerators. Pi over 4 is my reference angle. Okay, let's look at a couple more, but this time it's negatives. Okay, we've got negative angles here. So if theta is negative 240 degrees, honestly, because my reference angle always has to be a positive acute angle, the first thing that I would do in these problems is I would find a positive coterminal angle. Okay, so remember, positive coterminal angle means I'm taking the measure that I'm given, which is negative 240, and you're either adding or subtracting, because we're talking degrees. In this case, I'm adding or subtracting 360 onto it. Well, I'm going to want to add 360 here to get it to be a positive number. And that's going to allow me to have, and I can stop there because now I have a number that's less than 360, but it's positive. So I know that negative 240 is going to be the same spot. The terminal side is going to be in the same spot as a positive 120. And that might be a little bit easier for us then if we're thinking about, reference angles. But once again, if I'm thinking about my terminal side, I'm thinking about, okay, well, 120 is going to fall then here in the second quadrant. Okay, so technically, if I wanted to draw my angle correctly, theta, I would move in a clockwise position. So there is my negative 120 degree angle. But then remember, I always want my reference angle to be formed with the x-axis. So my reference angle is right here. This is what I want to find, and it needs to be a positive. So that's why I am going to keep 120 in mind here, even though my angle is technically negative 240. Remember, in the second quadrant, that's going to be dealing with the x-axis closer to 180 than it is to 360 over here. So I want to use 180 and 120 to find my positive acute reference angle. So my bigger number is 180. I'll subtract 120 from it. And so that's going to give me a reference angle, which is 60 degrees. Okay. All right, if we take a look at the next one, we have a negative angle. So once again, I'm thinking about what's my positive coterminal angle, because that's going to help me then maybe a little bit faster be able to find out what quadrant is the terminal side going to fall in. So because I know radians, 2 pi is my full rotation, I want to have a denominator of 3 because that's what my problem is. So I had to multiply the bottom by 3, which means I have to multiply the top by 3. So that means that 6 pi over 3 is going to be then 1 full rotation. So I take my angle that's given to us. I'm going to put the negative on the top. And I need to get rid of the negative, so I'm going to have to add. So if I add 6 pi over 3, that's not going to get rid of the negative. So I'm going to have to add on another one. But by adding on a second one, that means essentially I'm adding 12 pi. And 12 is bigger than that 11. So that's going to be enough to get me a positive coterminal angle, which is at pi over 3. Okay, so if we're thinking about my radians, where does pi over 3 relate to my quadrants? Well, pi over 3, remember, is going to fall in the first quadrant. If you're thinking about our different triangles, remember, if you're thinking about it in terms of degrees, that would be a 60-degree angle. Okay, so that means that we're here in the first quadrant. And so, I mean, if I was to sketch a picture, I'm going in a clockwise position. Okay, there's my theta. Okay, because remember, this is technically 6 pi over 3. So because it was 11, I needed to not only do one full circle, but I had to then go around to get to that terminal side again. Okay, but remember, I want a reference angle. And my reference angle always has to be formed with the x-axis. So my reference angle is going to be this little angle right here. Okay, notice that my positive coterminal angle is already an acute angle. And so we don't have to do any adding or subtracting. Remember, when you're in the first quadrant, you already have acute angles. So right off the bat, I know that that positive coterminal angle that I just found, with it being acute, falling in the first quadrant, that's also my reference angle. All right, so I would suggest that you pause the video and try these 3 problems. All right, so notice that we're dealing with the point -3, -4. So if you think about where that's located in the third quadrant. So if you were to sketch a picture, you would be in the third quadrant. And here, let me just sketch it really quick for you. And remember, in the third quadrant, if you think about all students take calculus, only tangent is going to be positive. So there's my triangle. Remember, -3 would be this leg, -4 is this. Technically, it was a triple. It was a 3, 4, 5 family. And so then that's where all my ratios came from. But notice that once again, only tangent and cotangent have positive ratios because we're in the third quadrant. Okay, number 2, notice that negative angle. So I technically drew my picture as far as theta incorrectly. Okay, technically I want to have my angle look like that, but I want my reference angle. So my reference angle is going to be then dealing with my positive coterminal angle, which I've just found to be 295 degrees because I added 360 twice onto that angle. And then that told me that I was in the fourth quadrant, which relates then to 360. I had to subtract them. 65 degrees was my reference angle. Okay, 2 pi over 3 falls in the second quadrant. So that's going to relate then to my 3 pi over 3 value. So then that's why I just had to subtract them to get pi over 3 to be the reference angle. All right, so that was us using definitions of trig functions for any angle, talking about signs of trig functions, and finding reference angles.